Hey everyone, welcome back to another CS 128 Honors lecture. Today's lecture should be super short. We'll just be doing some quick review of ownership and borrowing, and then for most of the lecture, we'll be discussing the slice type, what it is, and how it can be useful. So let's do some super quick review of the basics of ownership and borrowing. So as you probably know by now, there are three rules of ownership. One, each value in Rust has a variable that's called its owner. Two, there can only be one owner at a time. And three, when the owner goes out of scope, the value will be dropped. So here are some examples that demonstrate these. In our first example, we have a variable s that owns this piece of data hello, and then we enter a new scope and define a new variable w, which owns world. After that, we might do something with w, but once we reach the end of its scope right here, its data is no longer valid, it's dropped. So W can't be used and nothing else can refer to its data. And the same thing applies for S once we reach the end of this outer scope. In the second example, this example demonstrates the second rule of ownership, which is that there can only be one owner at a time. So in this example, we have a variable S1, which owns this string hello. However, in the next line, the value owned by S1 is moved into S2, and S2 now is the one and only owner of hello. So after this line, to ensure memory safety, S1 is no longer valid. And if we try to use it like we do in this print statement, we'll get a compile time error. So now moving on to references. As we know, references, which are represented by the ampersand, allow you to refer to some value without taking ownership of it. So in this example down here, we're passing the class variable by reference to say hello. So say hello does not take ownership away from the class variable, and therefore we can use class again as we do right here. If we didn't pass by reference, the say hello function would take ownership away from class, and the class variable would no longer be valid after that first function call. So we would get an error when we reach the second one. And remember, there are some rules to borrowing or creating references. You can either have an unlimited number of immutable references, so references to data that you cannot change using that reference, or you can have one mutable reference. So in this example, it passes a mutable reference of s to the change function, and then that function changes s. It appends the world string. So this print statement would print out hello world if we were to run this code. Okay, so now let's move on to the slice type. To see its power, let's first do a programming problem together. So the problem is as follows. Write a function that takes a string of words separated by spaces and returns the first word it finds in that string. If the function doesn't find a space in the string, the whole string must be one word, so the entire string should be returned. So let's walk through how we might solve that. We know we need a function, so let's create one called first word. How should we write the signature for this function? Well, we could pass a reference to a string as a parameter, which would work fine since we don't need ownership of the parameter and we probably don't want to mutate it in any way. But what should we return? We don't really have a way to talk about a part of a string. So instead, we could return the index of the end of the word, which could be indicated by a space. If we reach a space, we know that we've reached the end of the first word, so we can just return that index. Now let's go over the body of the function. So we know we need to go through this string element by element to check whether a value is a space or not. So we can convert our string s into an array of bytes using the asBytes method. Next, we can create an iterator over the array of bytes using the iter method, followed by the enumerate method, which will return a tuple. The first element in the tuple is the index, and the second element is a reference to an element in bytes. Inside this for loop, we can search for the byte that represents the space by using this byte literal syntax. If we find a space, we can return the index, the position. Otherwise, we can return the length of the string using the length method. So now we have a way to find the index of the end of the first word in the string, but there's a problem. Since we're returning a usize on its own, it's only a meaningful number in the context of a string, in the context of s. In other words, because it's a separate value from s, there's no guarantee that it'll be valid in the future. For example, consider this program. This program will compile without any errors and would also do so if we called word after s.clear. But because word isn't connected to the state of s at all, word would still contain the value 5 even after we've cleared s. And if we try to use that value with the variable s to try and extract the first word out, we would receive a bug because the contents of s has changed since we saved 5 in word. Having to worry about like the index getting out of sync with the word or the data in s is tedious and pretty error prone. So luckily, Rust has a solution for us called string slices. So rather than a reference to the entire string, string slices are references to just a part of a string. So for example, hello is a reference to a portion of s specified by this 0.5 bit. We can create slices using a range. So we can specify a starting index, ... an ending index, where the starting index is the first position in the slice, and the ending index is one more than the last position in the slice. So internally, the slice data structure stores the starting position and also the length of the slice, which corresponds to the ending index minus the starting index. So in this case, world would be a slice that contains a pointer to the byte at index 6, and then it'll also have a length of value 5. So here are all the ways you can create a slice using Rust's range syntax. So you can have one with a starting index and a stop index, where the starting index is inclusive and the stop index is exclusive. You can have a range with just a stopping index. So in this case, Rust will just infer that you want to start at the beginning of the word, and then it'll go until the value right before stop. You can also have the same for start. So you could just have a starting index, and then Rust will just infer that you want to have the rest of the string as a part of that slice as well. And then if you wanted to, you could have a slice of the entire string, which would just be a normal reference. With all this information in mind, let's rewrite the first word function to return a string slice. So in the signature, we need to change the return type. The type that signifies string slice is written as &stir, which we've definitely seen before. To get the index for the end of the word, we can do the same thing as we were doing previously by looking for the first occurrence of a space. However, instead of returning the index, we'll return a string slice using the start of a string and the index of the space as the starting and ending indices. Now, when we call first word, we get a single value back that is tied directly to the underlying data. This is a much more straightforward API that's a lot harder to mess up because the compiler will ensure that the references into S remain valid. So in this code, if we were still using usizes and indices to track the end of the word, word would hold the value 5, and this would print the first word as 5, which is logically incorrect because S has been cleared. So this is a pretty big bug. Slices, on the other hand, would make this bug impossible and let us know that we have a problem with our code much sooner. In this example, using the slice version of first word would throw a compile time error when we got to this print statement because word now refers to nothing. because S has been cleared. Finally, let's move on to other slices, such as array and vector slices. They're constructed the same way as a string slice. You'll borrow part of the original data and specify a range with a starting and stopping index. It's important to note that vector slices will have the same type as an array slice. So this ampersand is a borrow, this bracket notation represents an array, and this T is whatever is in your original vector. So in this example, we have an array of I32s and a vector of I32s, but both of their slices will be arrays of I32s. Okay, that's all for today. Just as a quick reminder, homework 4 and MP0 are due tomorrow. Homework 5 was released yesterday and is due next Monday. And MP1 was also released yesterday and is due in 2 weeks on Monday, October 2nd. Okay, that's everything for today. Thanks for listening, and I'll see you guys next week.